Hello again, everyone. This time we're going to solve solutions to exercises in Lecture 3. So we are asked here to find the solution set of the following equations. Number 1, square root of 2 plus square root of y plus square root of 2y is equal to 2. And number 2, we have square root of y times square root of y minus 8 is equal to 3. Now, to solve for the first equation there, we need to square both sides of the equation and simplify. And to say, when we do that, we have here, we square both sides. This will give us 2 plus square root of y plus square root of 2y. When you square 2, come up with 4. So we have the following. Next would be to simplify this equation here, this one, by, again, trying to get rid of 2 here so that we are left with a radical, just one radical on one side of the equation. And to do that, we subtract both sides by 2. Subtracting this by 2, we will have square root of y plus square root of 2y is equal to 4 minus 2 will give us 2 here. And then we square this one again so that we will have y plus square root of 2y equals, when you square 2, that will give you 4. So we have the following here. You square both sides. You have that one. That is, you get rid of the outer radical sign there. And then subtract both sides again by y, so that you are able to isolate again this quantity which has a radical sign. So subtracting this by y and this one by y, come up with square root of 2y equals 4 minus y. Then you square this one again to come up with 2y equals the quantity 4 minus y squared. So we have this. And we can operate on the quantity 4 minus y squared, making use of the special product formula. It will give us 16 minus 2 times 4 minus y is negative 8y minus y, quantity squared, is equal to plus y squared. And then combining similar terms, we have y squared minus, we have 2y and minus 8y. That will give us negative 8y minus 2y, which is negative 10y. Then plus 16. And then we have y minus 8 times y minus 2, which are the factors of y squared minus 10y plus 16 equal to 0. So equal to 0 there. We have y is equal to 8 or y is equal to 2. But we are not sure yet whether these two are the solution set, so we have to verify by substituting these values to the original equation. And substituting these values would give us the following. You have the solution set is equal to 2. So let us verify that indeed the solution set is equal to 2. So we now verify to the original equation whether the values that we get will satisfy the equation. So when y is equal to 8, we have the following. That is, we now replace y here by 8 and y again here by 8. So that's why you have square root of 2 plus square root of 8 plus square root of 2 times 8, which will give us square root of 2 plus square root of 8 plus 2 times 8 is 16 there. And the square root of 16 is 4, so that we now have the following, that is square root of 2 plus square root of 8 plus 4. But square root of 8 plus 4 here is equal to square root of 12. So we have here this one. That is square root of 2 plus square root of 12. But that one is not equal to 2. So meaning to say y is equal to 8 is actually not a solution there. Now we check again the other value, that is when y is equal to 2, we substitute it to the original equation. That is following. We have square root of 2 plus y here is replaced by 2. So square root of 2 plus square root of again y here is replaced by 2. Equals square root of 2 plus square root of 2 plus this one is 4. So we have square root of 4. But what is square root of 4? That's equal to 2 here. So you have square root of 2 plus square root of 2 plus 2 here is square root of 4. And again, square root of 4 is 2. We have it here. So that's square root of 2 plus 2 square root of 4. And because it's true, then we say that when y is equal to 2, it satisfies the given equation. So it is actually the solution set. So the set is the set containing 2. Next, we try to solve the second exercise, that is square root of y times square root of y minus 8 is equal to 3. And to do that, we have to square both sides of the equation. And squaring both sides of the equation, we will now have the following, that is square root of y. When you square, you come up with y. Square root of y minus 8 becomes y minus 8. Square root of 3 is 9. And then distribute y to y minus 8. You will have y squared minus 8y. And then you add or subtract 9 to both sides. Sorry. Subtract 9 to both sides of the equation. So you have minus 9 here. So that becomes 0. And then factoring this will give us y minus 9 and then y plus 1. These are the correct factors because this will give us y squared minus 9y and plus y will give us negative 8y, and minus 9 times 1 is negative 9. So we have y equals 9 or y equals negative 1. But again, we have to verify whether this will give us the correct values to the original equation. So that we have the following: verifying whether these values satisfy the given equation. When y equals 9, we have here following. Let's see. Square root of y times square root of y minus 8. Is it indeed equal to 3? I have replaced square root of y by square root of 9. Square root of y minus 8 by square root of 9 minus 8 equals 3. But what is square root of 9? That's equal to 3. And square root of 9 minus 8 is square root of 1. So that should give us the following, which is 3 times square root of 1. And that is indeed true. So meaning to say, when y is equal to 9, it will satisfy the original equation. How about when y is equal to negative 1? Let's see, when y is equal to negative 1, we have following values. That is, you replace negative, replace the value y into negative 1 here, but that is not equal to 3. So y equals negative 1 is not a solution. Meaning to say the solution set contains only the set containing 9. That is 9. Because it satisfies the original equation.